the channel Knowledge Star Continuous Knowledge Excellence. My name is Karuna Singh. In this video, we will get to know about Electrochemical Impedance Spectroscopy, which is EIS, and advantages of Electrochemical Nanosensor. Now our expert, Professor Himadri B, Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Delhi Deccan Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics, biophysics. Will explain you in detail about this topic. So, to get complete information, watch full video without skip.
So either we measure the current or we measure the impedance of the cell. I told you that there is a double layer, which is basically just capacitance, and there is a resistance corresponding to the electrolyte. And the analyte, when it enters the working electrode, it faces certain resistance on the way, which is called the charge transfer resistance, because the charge is being transferred from the electrolyte, from the analyte to the electrode surface, and it faces certain amount of resistance. It also passes through a capacitance, which is the double layer here. And the entire thing here, it is drawn into an electrical circuit here. This is the solution resistance. This is the charge transfer resistance. This is the capacitance I am talking about, this one. And that this circuit is actually RC, parallel circuit, which has got a impedance value. Impedance is basically the voltage by the current. Voltage divided by current, as you know, in Ohm's law, is the resistance. When these things become dependent on the frequency, then the resistance becomes a impedance parameter. The voltage is a function of frequency, current is a function of frequency. Then the resistance is called an impedance. It impedes the flow of current, and that value is given here with the circuit parameters here, the solution resistance, this is the charge transfer resistance, and this is the frequency, charge transfer resistance, and the capacitance of this dielectric layer here. So this is another way of looking at it. Either look at the voltagram that I showed you, or you look at the impedance of the cell. People also analyze the impedance of the cell, try to get the same information. Now, I told you when you do the impedance here, there is a Z prime frequency, which is the real part, a Z double prime, and frequency is the imaginary part of this thing. And these two things are plotted here. Imaginary part, ohms, real part. You will get these beautiful semicircles, and there is a straight line beyond this one. How is this interpreted? See, look at one particular curve and see that the distance between 0 to starting of that curve here, this is the solution resistance.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
Now follow the semicircle, and where it hits the x-axis is what is your RCT value, or charge transfer resistance value, but RS is sitting here already. So this is RS, R solution, plus the charge transfer resistance, RS plus RCT. Beyond this, there will be a straight line. This is a completely resistive region. Now, when you plot this, this implicitly understood that you are going from high frequency to low frequency measurement. High frequency measurement, you are basically probing the chemical reactions that are happening inside the solution. Low frequency measurement correspond to slower process, relaxed processes like diffusion. This is chemical reaction, highly reactive, fast processes. This is slow processes, diffusive processes. This is plotted here. Frequency and the magnitude of strength of the impedance. When you are at a very low value of frequency, millihertz, this is like a Ohm's law circuit. It's just Warburg resistance, what is called. Then you reach this point. This is a charge transfer resistance here. At certain frequency, this becomes important. Then the capacitance contribution becomes important, which is a double layer capacitance. And finally, very high frequency, the chemical reactivity becomes dominant. That is called the R solution or RS. This is the same thing that I showed you in the previous slide. So by looking at the nature of this curve, then you know the charge transfer resistance, you know the solution resistance, or you also know at what frequency your cell becomes completely ohmic cell. It shows only a response which is like a normal electrolytic cell, not an electrochemical cell anymore. So this is how the impedance analysis behavior takes place. Yeah, this I have already said earlier. So now, when I put all these things in the background, the advantages of electrochemical sensor is it's very reliable detection, high sensitivity, got very good selectivity. Requirement of the sample is small. You can work with very dilute solutions. Highly quantitative process. You can measure various parameters like diffusion coefficient, charge transfer resistance, the redox behavior of this thing, redox potential of the chemical of the analytes. Also important is it can be made field applicable. Okay, these are the advantages associated with this instrument. Nowadays, there are pocket electrochemical cells or cyclic voltammeter instruments are available at a very low cost, low price. But all those things work on this principle.
I hope you liked this video. Here, I would like to give you an important information that Nanoscience and Technology Consortium or NSTC organized the nanotechnology workshops on very interesting topics. Also, I would like to tell you about the initiatives of NSTC in which you can also be a part of. Mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. So yes, that's all. And yes, there is one more thing, that if anybody wants the recording of the previous video, then they can contact us on info@nstc.in. Further, if you want to enroll in the upcoming workshop, so you can go to the website www.nanoschool.in. Further, I would like to tell you that if you want to see these type of videos on this channel, so please do subscribe to the channel and please do comment. We will definitely reach out to you. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.